Hey guys, Chavez here. Thank you for joining me on my spring break adventure. We're going to tackle this one question, guys. I hope that you guys have a good time doing this question, or I hope that you guys already did. I don't know, maybe you already tried it out and you're trying to see how you fared with this one. Yeah, let's get into it, guys, and I hope you enjoyed. I hope you're having a good time in spring break. And yeah, let's have a little bit of fun here. So this is a calculator active question. It's from the 2004 AP exam. Yay. And let's try it out. It says a particle moves along the y-axis, so it's either moving up or down. So its velocity v at time t greater than or equal to 0 is given by, and here's an expression that describes my velocity. At time t equals 0, the particle is at the y equals negative 1. Alright guys, so we have a particle, and it's just literally just moving up or down. And that's all that's happening. So the first thing I would do, I would type this equation into my y1, into my calculator. So let me get my calculator here. And here's my calculator. I'm going to go ahead and go to y equals. And I'm just going to type that in. 1 minus, and it's arctan. So I'm going to push, make sure you're in radian mode. Second arctan and e to the x. So I'm going to type in e, which is going to be right there in blue. Where the ln is at, so I gotta push the second button, E, and then the X, bam, scroll down, there. And just in case, I'm gonna click on mode, make sure I'm in radian, and I am, so I'm in radian. So let's go back to y equals, there it is. I got it in y1. So let's see what they want me to do for letter A. Find the acceleration of the particle at t equals 2. This is a calculator active question, guys. You do not have to show the derivation, but you do got to link it. So how do you get acceleration from velocity? Well, you got to take a derivative. So the way you would do that, you would just simply show, I'm going to go a of 2 is equal to v prime of 2, which equals, and I'm just going to write down what that derivative is at 2. So here it is. I'm going to take out my calculator, and I already have it in y1. Remember that, guys. So I'm going to push math. I don't think it's number 9. I think it might be number 8. Yeah, number 8. And I'm going to push enter, ddx, and then I'm going to push alpha trace y1. If you want to type it from scratch, that's fine, at x equals 2. And I'm going to push enter, and there we go. Make sure to get that negative there, guys. Negative 0.1329. Negative 0.1329. Negative 0.1329. That is the point, the decimal there. And that's it. We're done. Is the speed of the particle increasing or decreasing at t equals 2? Give a reason for your answer. All right, there's two ways to do this. One is to look at the graph, the velocity graph, and see if I'm moving away from the x-axis at t equals 2. Now, I don't know if that's going to be enough justification. Like if you literally write, oh, it's I'm moving away from the x-axis, so particle is speeding up. I think the best way, that's one way, but another way to do it, guys, is to look at the velocity and acceleration. Remember, if velocity and acceleration have the same sign, the particle is speeding up. If velocity and acceleration have opposite signs, the particle is slowing down. So, again, I'm going to look at my velocity at 2. So the way I do that, guys, you can either look at a table, or I can just go alpha trace, and I'm going to type in y1. So my y1 at 2, so this is, remember, that's velocity. My velocity at 2 is negative 0.436. So there it is. I got my velocity. I have my acceleration. Because they are the same sign, the particle is speeding up. So let me see if I can write that down first. Velocity at 2 is 0.4362. Velocity at 2 equals negative 0.4362. Did I get that right? 4362. You could also say 63 if you wanted to, but that's fine there. Okay, is the speed of the particle increasing or decreasing at t equals 2? So here we go. I'm going to write a statement. The speed of the particle is increasing. Well, okay, now that I'm thinking about it, it's saying is the speed of the particle increasing. Yeah, the particle is increasing. Yeah, the speed of the particle is increasing since velocity at 2 and acceleration at 2 have the same signs. And there it is, guys. That's how I know that my at t equals 2. At t equals 2. The speed of the particle is increasing since velocity at 2 and acceleration at 2 have the same signs at t equals 2. There it is. We're done. Velocity at 2 is negative. Acceleration at 2 is negative. All right. Let's see. Find a time t greater than 0 which the particle reaches its highest point. Justify your answer. Remember, we are traveling either up or down, guys. So I'm going to look at my graph now. So I'm going to go to y equals, and I'm going to see, well, I'm going to click on windows, really. So y equals, there's my equation, window. So I'm going to start at 0, and I really don't have an idea how far to go to, but I'm assuming there's something's going on with that arctan. So I'm going to go to 5 for now, and I'm going to hover around the x-axis. So I'm going to go -1 to 1. And I'm going to push graph. Okay, look what's happening, guys. So my particle starts out going up because the velocity is positive. There's a velocity graph. And then I intersect it right here, the x-axis. My velocity is 0 for a moment. And then after that moment, the velocity is negative forever and ever and ever and ever and ever. So that means I went up and then bam. This is the only time that I changed my direction. That's it. That's the only time. So I'm gonna exaggerate this, guys, a little more. I'm going to go with y max equals 0.5. And I'm going to set my x max. Since it does it pretty quickly, I'm going to go to 2. And now we should have a better picture now. So that's it, guys. The only time it changes directions is right here. And that's it. This is the only time. I want you to observe that this is the only time that my velocity goes from positive to negative. So this must be an absolute max. So I'm going to find it. Second, calculate number 2. It's a 0. And left bound, so go to the left. Enter. And it says right bound, go to the right. Enter. Guess? Nah. And there it is. 0.443022. All right, so let's see if I can come up with a statement. 0.44302. 0.44302. T equals 0.44302. All right, so I'm going to say, when does the particle reach its highest point? So I'm going to go ahead and start writing a sentence here. The particle reaches its highest point at t equals 0.44302, as this is the only time the particle changes from positive velocity to negative velocity. Semicolon, indicating this must be a max or highest point. Indicating this must be highest point. Think about it, guys. If the velocity is positive, you're moving up. If the velocity is negative, you're moving down. So if this is the only time the velocity changes from positive to negative, then that is the time where it's going to be the highest. Let me see if it reads properly here. The particle reaches its highest point at t equals 0.44302, as this is the only time the particle changes from positive velocity to negative velocity, indicating this must be highest point. Perfect. I think that's full credit, guys. I didn't do a super awesome smiley there. There we go. Now it's better. All right. Letter D, it says, find the position of the particle at t equals 2. Is the particle moving toward the origin or away from the origin at t equals 2? Well, let's see. Do we know where we are at 0? We do. At t equals 0, the particle is -1. So my position at 2, so I'm going to write my position, because remember, it's a y value. If it were an x value, I would write x. My position at 2 is equal to my position initially plus the displacement from 0 to 2. And the way to get displacement is to integrate velocity. So I know that y of 0 was, I already forgot it. Y of 0 is negative 1 there. So negative 1. And I'm going to add whatever this is. So let me get my calculator again. And let me integrate. So I'm going to go second quit. And I'm going to show the integral symbol, math number 9, 0 to 2. And I'll put y1 in there, alpha trace y1, dx. I'll push enter. So I'm going to add negative 0.360688, negative 0.3, I already forgot it, 360,688, and so here we go. I'm just going to push plus negative 1, really. Plus, I wonder why my little pencil doesn't work. Plus negative 1. So I'm at negative 1. Oh my God, Chavez, did you really do that? Yeah, I did, guys. As you can see, it's because it's 2 in the morning, so I can't believe I did that. Negative 1.3606. So there it is. Negative 1.3606. Now they want to know if it's moving towards the origin or away from the origin. Now, I believe I remember what my velocity was at 2. My velocity at 2 was negative. So since my velocity is negative and my position is negative, so think about it, you're moving either up or down. So I'm going to say this is 0 right here. So if you are down here at negative 1.3606 and the velocity is negative, meaning you're going down, you must be moving away from the origin. So I'm going to write, since y of 2 is negative and velocity at 2 is negative, comma, particle moving away from the origin. All right, we're done. Let's see if we got all the points, guys. So let me take out, let's take out that rubric. Math Life. It was a spring break one. Let's see. I think we got letter A, perfect. Letter B, speed is increasing, says acceleration and velocity have the same signs. That's what it means there. Acceleration is negative, velocity is negative. Letter C is the only critical value for y, blah, blah, blah. Yeah, we got it. We got it all. This is saying, literally this right here is saying velocity is positive between 0 and ln of tan 1. Velocity is negative for all values larger than ln tan 1, which is at 0.443. Hence, that must be an absolute value. They did it with math and with symbols, and I did it with words. Same thing, guys. Bam. I like it. The particle is moving away from the origin since blah. Perfect. All right, guys. I hope that you guys liked that. I thought it was pretty cool. And hook it up with a thumbs up and let me know how many points you guys got. All right, guys. Talk to you guys later.